Hello again, everyone. This is Mr. V. Hill, and today we are going to be talking about sequences. And so first off, well, I have written up here already the definition of a sequence. And a sequence is, right here, a function whose domain is the natural numbers or the whole numbers, either one. And hopefully you remember what a function is from last year in 7th grade and what the domain of a function is. A function is just a relationship from one set to another set, such that any input is assigned exactly one output. The domain is a set of all the inputs. Hopefully you remember what the natural numbers are. Those are just the counting numbers because it's natural to count with them. 1, 2, 3, 4, 5, 6, and so on. The whole numbers are the natural numbers, but we also throw in the number 0. And mathematically, it doesn't matter whether you want to use the natural numbers or the whole numbers as the domain of a sequence. They're completely equivalent. You can transition back and forth between the two. Generally speaking, we're going to be using the whole numbers, including 0, for reasons that we'll get into in just a little bit. But anyway, so this definition right here is, well, obviously kind of mathy. And so an alternative definition that I kind of like, because it kind of gets the point across a little bit better, especially to relatively new math students here, which you all are. So alternatively, a sequence is really just, well, it's a bunch of things placed in a specific order. Meaning that there is a first thing, a second thing, a third thing, or for our purposes, most of the time we're going to be using the whole numbers, so there's a 0th thing, and then a first thing, and then a second thing. I know this sounds a little bit weird, but it'll make the math, what we're going to get into, quite a bit easier looking at it this way. So for example, and if you don't already know this, these letters e.g., that's the abbreviation for the Latin phrase exempli gratis, meaning a free example. So let's just look at a sequence here. Let's go, yeah, why not? 2, 5, 8, 11, 14, and so on and so forth. And if you stare at those numbers for a little while, you'll probably start getting an idea of what the pattern is in this particular sequence. So you notice this is the first thing, the second thing, the third thing, fourth, and so on. Or for our purposes, this is going to be the 0th thing, the first thing, the second, and so on. So these values in here, and they don't have to be numbers, of course, they can be whatever you want, really. Shapes, colors, whatever, it doesn't matter. But we call these things the terms in the sequence. And each of these terms has a specific term number or a place value or placement in the sequence. I'm just going to call it the term number. I'm going to make a little table here to show you what's going on. And we also, with this, we're going to have a certain kind of notation that you may have seen before, but it's using subscripts. Okay, so right here we start off, so the term here we have 2, 5, 8, 11, and it keeps on going, of course. And these ellipses dots are going to say that, well, the pattern keeps going on as is showing up so far. So we're going to call this 2, that is the 0th term. So it's term number 0, or we might call it the 0th term. The 5 would be the first, 8 would be the second term, 11 would be the third, of course. And so this is where we get the domain idea. So this would be the independent variable, the term number. The dependent variable, the term itself, depends upon what place it has in the sequence. And so just some subscript notation here. We often use the letter A as saying that we're talking about a sequence. You can use other letters too, it doesn't really matter. But we're going to call 2, we'll call that A sub 0, meaning it's the 0th term in the sequence of A's. A sub 0 happens to be 2. A sub 1 happens to be 5. A sub 2 happens to be 8. A sub 3 happens to be 11. And so on and so forth. And that's just somewhat handy. It's just notation, not a really big deal. Better just to really understand what the sequence is, which is really just a bunch of things placed in order. And we need some other stuff to be able to talk about these sequences. And a nice, easy way to describe these things is what we call a recursive rule. And I've got what a recursive rule is written up already over here. And so it's just a way of describing a sequence. But we describe the sequence by first specifying the first term, or sometimes we do have to specify more than one term to start the sequence off. For our purposes right now, we're mostly going to be focusing on just you'll only need one term. But we'll see other examples where you need 2, 3, so on and so forth as we go along. So you specify the first term or terms, and then also how to get to any term from the previous term or terms. So if you know the second term, you can get to the third. If you know the third, you can get to the fourth, and that sort of thing. So like for this particular sequence, 2, 5, 8, 11, and 14, well, we start with the value of 2. So a recursive rule for this would be, we'll start with 2, and then we need to know how to get to the next term from the previous one. So how do you get to 5 from 2? Well, obviously you just add 3. Does that work for the next one? How do you get to 8 from 5? Well, you add 3. How do you get to 11 from 8? You add 3. How do you get to 14 from 11? You add 3. So that's how you get to any term from the previous term. You just add 3 to the previous term. So that's the second part of our recursive rule. Start with 2, and then we add 3 to the previous term. And so that's just using words and writing out in English language, and that's all great. But we can also use our subscript notation to write a recursive rule. And so, using the subscript notation, we would specify the first term, or in this case the 0th term, and say that a sub 0 happens to be 2. And then, if we want to get a sub n perhaps, n being a variable here, meaning a variable representing the term number, meaning 0, 1, 2, 3, or the 5th term, or the 100th term. So a sub n, you get that by taking the previous term, which would be a sub n minus 1. And to that we're going to add 3. So if we want to get a sub 1000, we take a sub 999, and then we add 3 to that. Pretty simple here. And again, this is just notation. It's not the most important thing in the world. You can also use function notation, if you remember that from last year, just using parentheses, a of n kind of thing. But the big thing to remember here is that you must specify the first term. That's very important. For instance, here we have our sequence 2, 5, 8, 11, and 14, yada, yada, yada. Obviously, you could just say, well, obviously, it's just you're adding 3 each time. But that's not enough to specify this specific sequence of numbers. Because if we had, say, I don't know, 204, 207, 210, 213, yada, yada, yada. Well, the same thing's going on here. We're adding 3 each time. But obviously, this second sequence is a very different set of numbers than the first sequence. So that's why you have to specify the first term in your recursive rule. Otherwise, it's not going to define a specific sequence. Okay? So those are recursive rules. Pretty simple there. The other way that we're going to be looking at of describing these sequences is something called a general rule. And a general rule is, well, I got it right here, a way of describing a sequence in which any term in the sequence is expressed using only the term's position in the sequence. And, well, what do we mean by that? Let's try one here. So, for example, I'm just going to give you a general rule here. We'll say that a sub n, meaning the nth term in the sequence, n being any whole number, well, you're going to get that by taking 3 times n, n being 0, 1, 2, 3, 4, 5, 6, 7, all the way up to infinity, and we're going to add 2 to that. Okay. So, if we had, say, like, so the term we'll put on top and the subscript notation on bottom. So a sub 0, we would get by taking 0 and just plugging it in here for n. So 3 times 0 is 0, plus 2. 0 plus 2 is, of course, just 2. Okay? A sub 1. Well, we take this 1, we plug it in for n. 3 times 1 is 3, plus 2 is 5. A sub 2. We just take 2, plug it in for n, right? 3 times 2 is 6. Add 2 to that, you get 8. And hopefully you're starting to see this pattern here. A sub 3. Take 3, plug it in for n here. 3 times 3 is 9, plus 2 is 11. And that would just keep on going like that. So we can get any term we want just by plugging in the term number into this equation here. And that's the basic idea, is the general rule is an equation that you can use to find any term in the sequence just by knowing what term you want. So for instance, if we wanted, say, a sub 1000, or the 1000th term in the sequence, we plug in 1000 for n. So 3 times 1000 is, of course, 3000. You add 2 to that, and you get 3002. No problem. That's the basic idea here. So there's the 2 different ways of describing a sequence, the recursive rule and the general rule. And the next thing we're going to get into is how to get to the general rule from the recursive rule. And it's actually kind of a neat thing. But we'll hold off on that until next class. So if you need to rewatch the video, take a little bit closer notes on this, go for it, and we'll talk about this some more in class.